This is the sandbox environment in LifeBrush. We hold two controllers. To navigate, we squeeze the grip buttons on the side of the Vive's controllers to pull ourselves through the world. We summon the VR menu with a button on the top of the Vive controller. To interact with the menu, we hold the controller parallel to the menu surface. Alternatively, we could have pointed at the menu like a TV remote, but we found this perpendicular position uncomfortable to use. A white cylinder indicates where the Vive controller is interacting with the menu. We hover over the Generative Brush and squeeze the trigger to select it. This is the example palette, and everything to the left are molecules and molecular agents that we can add to the simulation with the Generative Brush. We select the blue widget agents and paint them in empty space. In the VR menu, we select Simulate and play the simulation. These simple agents are interactive, and we push them around with the Push tool. We can also grab and throw them. Let's look at the Sculpting tool. The trigger controls the size of the brush. Let's add some material. To use the sculpted mesh, we save it to the environment. We choose the lipid bilayer molecular arrangement. We switch the Generative Brush to surface mode, and then we paint on our sculpted surface. This is a molecular arrangement that contains swarm agents. We use it to build our synapse, and here we add it to our sculpted mesh. Playing the simulation grows the grammar anchored to the surface. The filament tool gives us fine control over grammars grown along the brush path. These are some of the grammars that we can paint with. Selecting mRNA, we sketch an mRNA filament. Let's paint with CalQ and acetylcholine esterase tetramers. The grammar grows along the brush path and branches at the beginning and end. Using our Generative Brush, we select a ribosome with the large and small units already assembled. We add it near our previously generated mRNA filament. The ribosome uses tRNA to match mRNA codons to amino acids. We paint a cloud of tRNA near the ribosome. The tRNA molecular agents need amino acids, so we paint a cloud of amino acids nearby. Brownian motion brings tRNA and ribosomes together, but that takes a long time. However, our system is interactive and immersive, so we grab the ribosome and move it around. Now we see how the ribosome marches along the mRNA, with tRNA depositing amino acids onto a growing polypeptide chain in blue. We reach the end of the mRNA, and the mRNA and polypeptide chains are released. Using the swarm placement tool, we place seeds for a swarm grammar in the simulation, and the grammar grows. The gray spheres represent the construction agents executing the swarm grammars. The construction agents are driven by Brownian motion. These are the F-Actin and Tubulin molecular building block agents. The molecular building block rules can be seen in the back. We select F-Actin and paint an actin filament along the brush path. We start the simulation and see that filaments start to relax from a curved configuration into a straight path. Ripping out a monomer breaks the filament in two, and the two filaments do not interact. Placing the monomer back, the two filaments reassemble into a single filament. Let's play with tubulin. We paint a straight tubulin path. Now we paint a curved path. Tubulin is strong. It straightens out right away. The physical interaction tool pushes the tubulin apart, but it quickly reassembles into its low energy configuration. However, if we cause too much damage, the tubulin does not reassemble.